Hi guys, and welcome to Gen Chem. Today we are going to be covering redox chemistry and a redox reaction. In today's little video, we're going to be determining the oxidized element, the reduced element, what the oxidizing agent is, and what the reducing agent is. And before we hop into our reaction that we have in front of us, we're going to go over some brief rules. So to start, whenever you have a pure element, you are going to have the oxidation number be 0, always. When you're given a monoatomic ion, the oxidation number will equal the ion's charge. And when you work with oxygen, which has a few interesting rules, generally the case will be that you have a -2 oxidation state, and peroxides, O2 will have a -1 oxidation state. Superoxides will have a -1/2. And when you're working with fluorine, fluorine is going to be more electronegative. So you're going to have a positive, like when you have oxygen difluoride, you have a +2 or a +2 oxidation state. So let's hop right in and let's see how some of these rules apply, and let's determine some of what we are given up here at the top. So first thing we're going to want to do in an equation like this, or in a reaction like this, so we're going to want to determine the oxidation states for each element. So let's begin here with nitrogen and NH3. Well, we know that H is going to have a +1 oxidation state. So let's write that. And we know that the nitrogen is going to have to balance that out, and we have 3 hydrogens in this case. So you're going to need a -3 oxidation state on the nitrogen to balance out the +1 on the hydrogen, because there's 3 of them. Pretty straightforward. Now let's go to our O2. All right, in this case, we are given something like we talked about in our rules here when we're working with a pure element. So as we see here and as we know, the oxidation state for a pure element is always going to be 0. Easy enough. So let's go to our products. Here we have nitrogen again. In this case, it is paired with oxygen, and we know oxygen has the -2 oxidation state. So the nitrogen must have a +2 to balance it out. Next, we have 6H2O. So in this case, we have 2 hydrogens, 1 oxygen. Again, we know our oxygen is going to have a -2 oxidation state, and we know our hydrogen is going to have a +1. And there's 2 hydrogens, so that balances out with the -2 oxidation state of the oxygen. Now, let's determine the changes that occurred in our reaction. So first, let's start with our nitrogen. I like to write this down nice and neatly. So nitrogen starts as a -3 oxidation state, goes to a +2 oxidation state. Before we get into that, let's cover the next one. So hydrogen, in this case, has a +1 oxidation state, and it yields a +1 oxidation state. Now we have oxygen. Oxygen is going to have a 0 charge to begin with, and it's going to yield a -2 oxidation state. So now, how do we determine which element was oxidized and which element was reduced? When you're looking at nitrogen in this case, from -3 to +2, here, firstly, let's write down real quick. I'm sure a lot of you guys are familiar with oil rig. Oxidation is loss, reduction is gain. So in this case, nitrogen is going from a -3 to a +2. So it is being oxidized. And why is that? It's being oxidized because it is losing electrons. In the case of oxygen, we start at 0 and we go to -2. So that is going to be reduced. All right, because reduced is gain of electrons. So in this case, we are gaining electrons, and with nitrogen, we are losing electrons. So we can write that down now at the top. We simply know that nitrogen, or simply just N, is going to be our oxidized element, and oxygen, or just O, will be our reduced element. Okay, so now that we have determined our oxidized element and our reduced element, we are going to determine what our oxidizing agent and our reducing agent are. So in this case, we know that our nitrogen was the oxidized element and our oxygen was the reduced element. So they will always be inverted of each other, but be careful. When we talk about the agents for oxidizing and reduced, we are not just talking about the nitrogen and the oxygen. We are talking about the whole compound that is reducing or oxidizing it. So in this case, nitrogen is being oxidized. So we know that NH3 is going to be our reducing agent, not just nitrogen, but NH3, because NH3 is reducing our oxygen. So we can write that. And with oxygen, we know that it is being reduced, and so therefore the compound, which is the oxidizing agent, isn't just going to be oxygen, it is going to be O2.